In this video, finally, we're gonna, since we have run the analysis, we are just doing a check of our time periods. It's a complex model, and our IS code simplifies through some very basic formula to calculate a building time period. But since all of you might have complex models, it's better to model them in ETABS and find the time period from ETABS itself. So we have run our analysis, and please note that we have not specified any earthquake parameters. We've just defined them as empty load cases. We will do that later. We've only defined dead load, live load, and these combinations, which right now make little sense because we have added all earthquake combinations without really adding, let's say a zone factor data or importance factor or response reduction or spectral acceleration, soil data, anything. We have not added any of those. This is just a check. Uh, uh, to run and check my time period. Time period doesn't require any of those things. Time period exists. Uh, there's a time period for every object that you see around you, including a building. Doesn't necessarily need to have an earthquake. So what ETABS does is just sort of internally strike the building like a gentle tap on a pendulum, and it checks the amount of time it takes for the building to complete one oscillation. uh, and that it does, it's for different directions, so we're going to check in the X direction and in the Y direction. So nothing, is very simple. You go to display and show tables. This is where, after your analysis has been done, you'll see a lock symbol here, which means the model is right now locked. And you can go to display and show tables, and here in analysis results you go to structure output, and I'll click OK, and you'll see a lot of data here. I'm not interested in these forces right now. I'll go here and check for modal periods and frequencies. That's what I'm primarily interested, which is my time periods. Okay, so I'll go to modal periods, and here I can say that generally the first mode is the X direction, which is this, and the second mode is Y direction. So 0.405, 0.403 is my period right now, and that's what I'm basically interested in. Now you can compare this with the IS code formula and check how close you are, or how far off you are. If your building is pretty regular, it will be very close. Otherwise, it might be really different. But you anyway have to see this. This is a more accurate one, conducted through whatever internal calculations that this model has done. So X direction period is this, Y direction period is this. That's just generally how it is. The other ones are sort of rotational, twisting, all sorts of different dancing shapes. We're not really interested in those. This is X and this is Y.